Hello everyone, and welcome to this Spring 1 session. Today we are going to talk about Bitnami and service bindings. You may use service binding, you may use Bitnami already. It's a good way to get your favorite open source software up and running with any Kubernetes distributions. In this session, you will see how service bindings can simplify the use of Bitnami for your applications. My name is Alexandre. I am lead solution engineer at VMware Tanzu. I'm based in Paris, and today I am very pleased to host this session with my colleague, Chiara.
Hi all, I'm Chiara Salvatore, and I'm a senior solution engineer for VMware Tanzu in EMEA.
Great. We have a lot of stuff to cover, but don't worry, we will run live demos so you can have a better idea of what you can do with service bindings and Bitnami. Over to you, Chiara.
Okay, thanks, Alex. Let's start. So, when coding a new application to be deployed on Kubernetes, you likely need to find the correct way to bind your code to a database or any other external services. So you have your application, you know you need to store your app data somewhere, and you just want to connect to a database and send your data to it. Something like this. Smooth and simple, you say. Well, not really. Actually, you need someone, maybe an ops colleague, who gives you the credentials or who creates the secret for you. And then, hold on, these are the credentials for the dev environment only. What if you need to deploy to a prod environment? Do you have to open another internal ticket? Yes, likely you have to. And you also need to change your config files accordingly. Well, you know, in the Kubernetes ecosystem, the process of binding your app to services can be achieved in different ways. You can use environment variables, you can use secrets, init containers with vault, and many other ways. Moreover, each service provider often suggests their own distinct method for accessing secrets. And finally, don't forget that each framework can use a different approach to deal with sensitive data. So while this flexibility has advantages, it often hampers your overall efficiency as a developer, since you have to deal with numerous bespoke solutions. And this lack of standardization, this lack of consistency, slows down your productivity and your efficiency. So what if you could have a standardized approach to workload service binding? Well, let's start from scratch. Let's begin with our specific need, that is, an application running in Kubernetes that has to communicate with an external resource, such as a REST API, a database, a message queue, or any other service. This application typically requires certain credentials or access tokens, and these credentials may include usernames, may include passwords, API keys, or certificates. But how can we link these credentials with our application? Here it is, service binding. But what is this service binding? Well, service binding is a Kubernetes specification that offers a standardized and automated way to provide these credentials to the application securely. So service binding eliminates the need for developers to manually manage and configure secrets within their application code or deployment files. Instead, it is the Kubernetes platform that handles the process of retrieving the necessary secrets and injecting them into the application runtime environment. So by using service bindings, developers can focus on writing application without worrying about the specifics of how to securely access external services and without dealing with complexity. Well, the binding mechanism ensures that the credentials are securely transmitted to the application and that they can be easily rotated or revoked. So to summarize, service bindings in Kubernetes streamline the process of connecting applications to external services. And service binding achieves it by automating the retrieval and injection of necessary credentials, enhancing security, and promoting standardized practices across the Kubernetes ecosystem. So how can service binding specifications boost your productivity? As a developer, you can focus on your code without the need to deal with service credentials. As a service operator, you can keep your control on security, allowing developers to use your services without exposing service credentials and with a clear separation of concerns. And finally, as a platform operator, you can allow a smooth use of your platform and reduce the time to market. But why is a clear separation of concerns so critical? Well, because if the operators manage all the configurations, it means that there are no custom configurations at the application level. So your application can be smoothly deployed across many environments. You'll then enhance the portability and scalability of your apps. So how can you leverage service binding in your Spring apps? You can do it with Spring Cloud Bindings. Spring Cloud Bindings is a Spring Cloud framework library that implements the Kubernetes service binding specification and provides a simplified and declarative approach to connecting and binding external services to Spring Boot applications. And if you build your container images using the Spring Boot Maven or Gradle, you can invoke it with the Maven Spring Boot build image command. In fact, all you need is included in Paketo buildpacks. And for those who don't know, buildpacks transforms your application source code into OCI compliant container images. Paketo buildpacks is an open source project that provides production-ready buildpacks for the most popular languages and frameworks, including, of course, Java and Spring. Paketo buildpacks are leveraged by many application platforms and by local development tools, including Pack CLI, Spring Boot, Tilt, VMware Tanzu Build Service, and VMware Tanzu Application Platform. The core idea behind Spring Cloud Bindings is to abstract away the complexities, is to establish connections and inject necessary configurations into Spring Boot applications. So how does it work? Well, when your Spring Boot application starts up, Spring Cloud Bindings automatically configures the necessary components and establishes connections with the bound services, retrieving the required credentials and connection details from the configuration properties and environment variables. Once the binding is established, your application can seamlessly interact with external services using Spring Cloud abstractions. For example, you can use Spring Data for database access. You can use Spring Integration for messaging, or Spring Cloud Config for centralized configuration management. Spring Cloud bindings support an extended range of services with different purposes. You can use MongoDB, Redis, RabbitMQ, Cassandra, Elasticsearch, Kafka, Postgres, and many others. And for each service, there is an auto configuration mode and the possibility to map the service bindings configuration attributes to Spring Boot configuration properties. Soon, Alex will show us Spring Cloud bindings in action. But before that, let's have a look at all those external services come from. Well, many external services already come with service binding compatible secrets. So you only need to reference it in the service binding configuration YAML and port it to every environment you want. And part of these services can be deployed using Bitnami. And what is Bitnami? Well, with over a decade of experience publishing an extensive library of open source applications, Bitnami is an application packaging and publishing company acquired by VMware in 2019. And Bitnami provides an application catalog with more than 180 applications that you can leverage immediately in the format you require, as they are pre-configured and ready to use. Finally, in April 2023, Bitnami packaged data services and charts started supporting service bindings for Kubernetes. So removing the complexity around data services configuration and around secret retrieval processes. Let's see now with Alex how Spring Cloud bindings, Bitnami, and Tanzu application platform can work together smoothly to offer you the best developer experience and velocity. Alex, over to you.
Great. Thank you, Chiara, for this introduction. Exactly. We were going to see how you can use Bitnami with service binding and Spring Boot, including Spring Cloud bindings, to connect one application to some database. In order to do that, I have a demo application. So this is my application. So basically, you have a front end, which will connect to the backend to get famous quotes from video games, movies. And the idea is to connect this backend to my database. Okay, so this is my application. As you can see, my application is already deployed. It's already running. So we can have a look at this. Let's see if we can click on this. So this is my Tanzu application platform. I can have a view of my application and all the components. So as you can see, we have the main entry point for my application. We have the backend, we have the front end, and then we rely on some database to provide the quotes. There is also some API. So as you can see, my application is actually deployed to different cloud providers. So let's have a look. We have the API for this application. So you get the idea. The backend would call this endpoint. So let's do that manually. And this is how you get quotes from the backend, right? There is also one more endpoint that you may want to use, status. So if you execute this, you get some technical information about the application. And we are going to use this endpoint to see how we are connected to the database, right? So my application is deployed, as you can see, on different clusters. So let's have a look. My application. So this is the backend. So it's pretty simple, actually. It's a pretty simple Spring Boot application. And Right now, this application, if we switch back to the instance, so as you can see, it's running live, and now we are about to use the API status, and you can see that we are not using a database, actually. The application is running fine, okay, but we do not have a database. We are running with HSQLDB, which means basically we have no persistence. So if I kill the pod, then I will lose the quote. So as a developer, I need some database. So how can I do that? So the idea is to rely on my platform to get a view of the services that I can create. So this is the command I can use. As you can see, my platform operator has provides me with some templates I can use. So let's say I want to use the PostgreSQL database. It is a Bitnami service, actually. So let's do that. I'm about to create a new instance. So let's call it modd-db. And I want to use this class. Okay. And this is the namespace where I deploy my application. Okay. So let's create that. On this screen, you see that there is a new namespace. And as you can see, there is a new database which is about to be created. As a developer, I don't have to care. I don't need to care about the configuration of the database, how it's running, the memory, the storage class used by my application. It's all managed by the platform since the platform operators already made the configuration for me. And the database is up and running. So let's see how we can connect to this database. Let's switch back to the IDE. So this is the definition of my my application. So what I need to do, I would copy paste this definition. Remember, I am using a mod-db. So let's add it to the definition. And we are ready to apply this to my cluster. And that's it. I don't have to deal with this database. My platform will take care of rebuilding the app and make sure that when the app is running, we will get the right credentials that we need in order to connect to the database. So it's just a matter of seconds. So the configuration is applied, and in a few seconds, what we will see is a new pod for the moddb-backend. So this backend will actually connect to the database. So let's have a look. Under the hood, what you don't see is the service binding. So if we look at this, you see that there is a moddb backend for the configuration. And if we wait a few seconds, it should be up in a few seconds. We will get the database. Here we are. You see the new configuration is about to be applied, and we have the new service binding. So let's have a look. This is the service binding, which was generated by the platform. You may want to write this service binding by yourself. It's actually pretty simple. You have to provide some name, and then you have to connect somehow your application with the database, okay? And service binding will take care of injecting the credentials into my application. As a developer, I know nothing about the database. What is the host name? What is the username, the password? I don't know. I have no idea. The platform will take care by leveraging service binding. So the platform will take care of injecting those credentials into my application. And if we look here on the right part, you see that we are now using the PostgreSQL application. Please note that I don't have to restart the application. Everything is managed for me. And if we go back, then you see that we are now connected to this database, and you can refresh and get some new quotes from the backend, right? Okay. So now we are going to do much more. So let's focus on this. So we have the application. Remember that I am actually deploying this application to different cloud providers. So this is the configuration. So you see on this screen you have the application running on Google Cloud, as you can see, and here you see the same application, another instance running on Azure, as you can see. My application on Azure, if we look at the backend, we can open some shell. So let's go inside the container. What you don't see is service binding will take care of injecting the configuration that I need. So as you can see, there is this environment variable, service binding root. So if we go inside this path, inside the container, what you see is some directory. And inside the directory DB, then you see the credentials that you need to connect to your database. So let's show this, for example. This is the host name that my application will use in order to connect to the database. I don't have to care about this. Spring Cloud Binding will discover this binding, this directory, and will map those properties to Spring Boot configuration properties. So for a Spring Boot application, you will end up with a spring datasource.url, for example, in order to connect to the database. If we look at the Google Cloud instance, we can use the API. And here we see that, oh, we are not connected to some database. We're still using the embedded database. And that's a shame. So what can we do? Instead of using Bitnami, what we can do is, without having to rewrite the application, I have already created some Google Cloud SQL database. So what I want to do, when people deploy applications to Google Cloud, I don't want to use Bitnami services. I want to rely on some cloud managed database. So I have this database, which was created earlier by the platform operator. Here, how you can do that on my platform. I use open source projects such as Crossplane, for example, to create this database. So it's basically a Kubernetes entity that you use, and then Crossplane will take care of creating the resources on the cloud I'm using. So it's like Terraform, but all running inside the cluster. And now what we want to do, we want to switch from the default database to the Google Cloud SQL database. And in order to do that, what I need to do, I need to provide some service binding, okay? So this time, as a platform operator and as a service operator, actually, I would create the service binding, okay? Remember that there is no need to involve the developer. This time I want to connect the application to the Google Cloud SQL database. As you can see, this is my app, the backend, and I want to connect to this moddb-backend-db. Okay, so all I have to do is to kubectl apply this file. And look, as you apply this configuration, there is a new pod. So this time it's started quite fast. So there is the new configuration, which will be mounted as a volume inside the pod. And if you look here, you have the API status from the backend. At some point, we will automatically switch, as you can see, to the PostgreSQL database. It is actually a live version of PostgreSQL database and managed by Google Cloud SQL. Let's have a look. If we go inside the pod and if we open a shell, then you will see the host name that you need in order to connect to the database. We can also have a look here. If we refresh, if we hit refresh, you should see the latest deployment. So let's focus on Google Cloud. Okay, you see the deployment, and I want to look at the pods. Okay, so this is my pod. As you can see, this is my application. And now what I want to see, I can get access to some information such as the threads, the memory of my Spring Boot application. But what I want to see actually is the configuration properties. And if we look for data source, you'll see that a spring.datasource.password, hostname, URL was automatically set by Spring Cloud Bindings. And this is how you can connect, how you can bind your application to some database. Okay. We also have a great feature. You can also use this application and Spring Cloud Binding not only for databases, but also for configuration. So this is my configuration for my application, which is backed by a Git config. So if we look at this, let's go back. We can edit the configuration, right? So this is what we are going to do. I'm going to edit the configuration for the backend. So on Azure, instead of using quotes from Yoda, I would enable quotes from Elder Scrolls. Let's commit. And for Google Cloud, same thing. I don't want quotes from Chuck, but from Back to the Future. Okay. The thing is, this configuration is actually loaded by the platform as a service binding. And as soon as you update the configuration, the same way, the pod will be restarted with the new configuration, which will be mounted as a volume inside the pod. So at the end of the day, you can use service binding to connect your application to databases, to service brokers, to a lot of services that you can use. You have Bitnami integration, and you can also use it to get configuration. And if we hit refresh, then you get the new quotes from Back to the Future. And on the lower part, we have quotes from Elder Scrolls. So that's a good way to rely on Spring Cloud Bindings, service binding, and Bitnami to power up your application and simplify the use of services with your Spring Boot applications. And that's it for me. Let's go back to the presentation. So you see the application. By the way, you can get the source code for this application. So I would advise you to look at this Git repo so you can use it and run it on your own workstation. We already saw about this. I want to thank you for attending this session. If you have any question, feel free to reach out. I will be very happy to answer all your questions around Tanzu application platform, Spring Cloud Binding, and service binding. And if we want to go and dig deeper with Spring Cloud Binding, you have the documentation that you can use to get all the information about this great product. Thank you, everyone. Bye-bye.